So we're going to continue our discussion of how to describe quantitative data using numbers. We're going to continue that today. And so being able to describe the shape and the center are really important, right? We want to be able to describe whether it's approximately symmetric or skewed or whatever. We want to be able to tell where the mean and the medians are. But we can have distributions that have very similar shapes and very similar centers, but they are very different distributions. So here's an example. What is different about these two distributions?
Different spreads.
Yeah, they have different spreads. Now, spread is a measure of variability of the data. And so we specifically use the spread in our whole SOX thing, shape, outlier, center, spread. And we've talked about that the spread is listing the low value to the high value so that we can see where the numbers are actually located on a number line. So we really like spread as the way that you describe the variability. Also, SOCV doesn't really spell anything fun. But I want you to know that variability is really what we're doing when we use spread. And that's one way to talk about how varied the data is to say what the low and the high is. And so we're going to talk about some other ways that we can talk about the variability or the spread, how spread out the data is here at the beginning. So the first thing is something that you guys are very familiar with, range. What is the range of the data? Yeah. So if I take the maximum value and I subtract the minimum value, I'll get the range. Now, the thing about range, and I think we talked about this before, is that it does not give data's location. So range is all fine and good to tell me how big of a difference there is between the high and the low, but it doesn't really tell me where. So yeah, there's a difference of 50 in the data. Okay, but we have an infinite number line, so where's this data at? So range is okay in some senses, but one thing about range we want to make sure we notate is that range is a single value. So if, for some reason, you are specifically asked to give the range, make sure you are literally giving the maximum minus the minimum. Don't say the range is from 1 to 10. Well, if you're asked for the range, make sure you actually do the math. Okay. Think about this question for a second. Do you think range is a resistant measure of spread? Do you think range is resistant? So the definition of resistance is that is whether or not it is influenced by extreme observations. So resistance is whether or not something is going to change when extreme observations change. So with that being known, what do you guys think? Is the range resistant?
No.
Why not? Yeah. So the answer is no, and it really takes one very quick example to prove this. So my very favorite data set, 1, 2, 3, 4, 5, it has a range of 4. If I change the extreme value of 5, if I change it to 50, what is now the range? 49. Did the range change? It sure did. So therefore, it is not resistant to those changes. So the range is not resistant. Cool? Cool. What else is not resistant? Mean. Very good. Very good. All right. The next thing we're going to talk about is quartiles. What's a quartile? It's like a quarter. A quarter of what?
The data.
The data. Very good. So what are quartiles? Well, they are going to be chunks of 25% of the data. So I'm going to chunk my data into 25% sections. So how do I find that?
You divide it by 4.
Kind of ish, sort of. So when I find, let's say I have my data set and I find the median, what percent chunks do I have at that point?
50.
I have 50 and 50. So how could I then get 25, 25, 25, 25?
Find the median of the median.
Find the median of the median, you got it. So the first step is to find the median. Find the median of the data. So that's going to put your data into two different sections, 50 and 50. Then you're going to find the median of lower half of data. We're going to find the median of the lower half. What do you guys think the median of the lower half is called?
The first quartile.
That is the first quartile, or quartile 1. This is quartile 1. That is notated with a capital Q and a little 1 in the little subscript. Q1. You can call it the first quartile, the quartile 1, or Q1. You could say any one of those things. That's the first quartile. And then we're going to find the median of the upper half of data. So we'll find the median of the upper half of data. What do you think that is called? Why 3? Why not 2?
The medians, 2.
This is quartile 3, or Q3. So let me draw you guys a visual of why it is Q3 and not Q2, which is what most people would say it is. So we have our minimum, and then we have our maximum. Okay, we just have our data listed out, lowest to highest, boom, boom, boom. We find the median. What we have just done when we found the median is we have 50% of the data on the left, and we have 50% of the data on the right. And then when we find the median of the lower half, we have just cut that 50% into 25% and 25%. And so the first 25% is quartile 1. The median is technically the second 25%. So technically the median is Q2, but I promise you, you will very, very rarely hear anybody call it Q2. Everyone just calls it the median. Okay? Then you find the median of the upper half of data, and now we have 25%. This is Q3, and then we have our final 25%. So what is the maximum technically in terms of quartiles? It's technically quartile 4, but you're never going to hear that either. Okay?
So, is quartile 1 like the entirety of the 25% the minimum?
Yes. So quartile 1 is this whole section here, but we use Q1 as a number. So we're going to say like Q1 is like 15 or whatever, and let's say the minimum is 10. We'll say Q1 is 15, meaning 15 cuts off the lowest 25%. And the median is whatever it is, and it cuts off the lower 50%. And Q3 is 87, and it cuts off the lower 75%. So that's how that works. So it's kind of like you're notating where the cutoff is for the lower whatever percentage. Now, I do want to notate real quick that this is a very pretty, symmetric set of data, whatever it might be about. I have no idea what it might be about. But we're talking about percentages. So here's what I mean. Here's why that's important. So let's say, for example, we have our minimum here and our maximum here, okay? And when I go and I start counting the data, let's say I have 8 data values. So let's say they look a little bit like this. Let's say that's our data set there, okay? I want to find the median first, the regular old median. So I'm going to come inward. And so my median is here in between those two. So here's my median. Then I would find the median of my lower half. There's my Q1. I would find the median of my upper half. That's Q3. What do you guys notice about the sections?
Median's not in the middle.
Yeah, like they're not symmetric, right? And the median's not in the middle, right? It's in the middle of the data, but it's not in the middle of the minimum to maximum necessarily. It's not in the middle value. It's not the middle value. It's not the average, right? The average would probably be about in the middle. But here's what doesn't change. This from whatever this number is to this is what percent? This is still 25% of the data. It's 2 out of 8, which is 25%. Q1 to the median is still 25%. It's 2 out of the 8 in the data. This big long section here is still 25% of the data. There's 2 out of 8 data points there. That's still 25%. And then this one is still 25%, even though it's not the same size as the others. So it could be any size. They could be any sizes, side to side, any width, if you will. But they are still 25% no matter what. Does that make sense? Literally always the hardest part about quartiles is you think they're supposed to be the same width. Not necessarily. They will vary in width, but they have the same amount of data in them, the same percentage of data in them. Cool? Cool. All right. So, quartiles are super fun, and now we're going to ramp it up even better to interquartile range. What is the interquartile range, also known as the IQR? It is a range between quartiles, but which quartiles?
1 to 3.
1 and 3. So the interquartile range is the range of the middle 50% of the data. It's the range of the middle 50%. Okay, so here's our values. We've got our minimum, our Q1, our median, our Q3, and our maximum. And I want to find the middle 50% of the data. Where does the middle 50% of the data start? Q1. Where does it end? Very good. So this is my middle 50%. The IQR is literally the interquartile range. And what is range? It's a number minus a number and becomes a single value. So my IQR equals, anybody know the mathematical formula? Q3 minus Q1. It is a single value. IQR is a single value. It's not listing Q3 and Q1. It is actually subtracting them and getting a number. All right, here's your challenge. Is the IQR resistant? Think about that for just a second.
It is. It's basically
Yeah.
median.
But it has to be.
All right, have a little discussion with your group. See if you guys agree.
I mean, it has to not be. It has to not.
Is the IQR resistant? See if you guys agree.
No.
All right, you guys, tell me what you think. Is it resistant?
Yes,
Why? Why do you think that?
because it's based on the median.
IQR is based on median, and what do we know about median's resistance?
It's resistant.
It is. So if I base something on a resistant median, it is also resistant. So, yes. IQR is based on a resistant median. Okay, that's all fine and good, but there's actually another reason that we could use to state that it's resistant.
It's a percentage based.
So it's not technically the percentage base necessarily. Think about resistance. The definition of resistance is that it's going to react to extreme values. And think about where the IQR is. Does it even take into account anything that's happening out in the extremes? Not even at all. Like, literally, the IQR cuts off the upper 25 and the lower 25% of the data and says, I don't care about you. And so, I'm basically cutting off the extreme values so they can't affect it. Okay? So, IQR cuts off outer 25% on each side where extremes are. So, you can't get to me, extremes. I'm in the middle. Take that. What questions do you guys have about IQR?
Absolutely not.
Absolutely nothing? Easiest thing you've done all year?
Sure.
Facts. All right, cool. Let's talk about the 5-number summary. Any guesses what the 5 numbers are in the 5-number summary? I've shown them to you a lot. All right. Let me ask again. Any guesses what values comprise the 5-number summary? The median is one of them.
The mean.
The mean is not one of them.
Median is like the fourth.
Like interquartile rank.
So,
Is it minimum quarter one, medium quartile 3 and max? That's so
there it is. There is the 5-number summary, ladies and gentlemen. Any number or any data set can be described by its 5-number summary. Now, I will say it's not a complete set of data. I'll show you why in just a minute. But here's an example of how you might see it. You literally might see a question that says, here is the 5-number summary. There it is. Here is the 5-number summary. And it will look like that. Sometimes, every once in a while, you'll see commas in between the numbers, but for the most part, with the 5-number summary, you'll see it's spaced out like this. So, in this specific example, what is the median?
5.
In this specific example, what is the minimum?
1.
What percent of the data is between 5 and 7?
25%.
What percent of the data is from 2 to 11?
75.
What is the maximum?
11.
What is the mean?
We don't know.
You'd have to calculate that.
5.8.
How would we calculate
Add
that?
them all together, divide it.
So we'd add all of these numbers together and divide by 5?
Can you take the average in between each one and then take the average around?
We add up the 1, 2, 3, 4, 5.
We can't do it.
So you can't find the mean.
That's even better.
We can't do it.
Okay.
You cannot find the mean from the 5-number summary.
You'll get.
Here's why. I don't actually know. Let me just be honest. I don't actually know if 5 is even a value in my data set. Think about those dots that I had earlier. I had 2, 2, 2, and 2. The median was not on a data value. I had to find the average of the two to get the median. So like 5 might not actually be a data value. Okay? So I can't guarantee these are even in my data set. Now that it is truly the median, sometimes the median is the average of the middle two, which could give you a value that's not in your data set. So we cannot find mean from 5-number summary. We cannot find the mean from the 5-number summary. We would have to have the actual data to find the mean. All right, so back to the 5-number summary. Minimum quartile 1, median quartile 3, and the maximum. How is the 5-number summary visually displayed? What kind of graph can I use to display a 5-number summary?
Box and whisker.
A box and whisker plot, also known as a box plot. Do you guys remember box plots?
Barely.
Aren't they fun? I'm going to draw you one. Whee! Bringing back some good old memories from middle school, maybe even late elementary school. So, where is the minimum?
It's at the bottom whisker.
It's at the bottom of this whisker right here. Where's the Q1?
It's at the end of the box.
The beginning or the end, the left end of the box. Where's the median? It's the line in the middle. Where's the Q3? The top of the box or the end of the box on the right, and the maximum is here. Ladies and gentlemen, this is only one representation of an infinite amount of box plots that you might come across in your life. I'm going to draw you another one. Here's another one. There's another one. I know, right? I know. So where's the minimum? Far left. Where's Q1? The beginning of the box. Where's the median? The middle of the box. Where's Q3? The right side of the box. Where's the maximum? All the way down there.
I don't care about that all the way over there. No.
That's right. That IQR, I don't care about that all the way over there. Let's go. You right? I have a question for you guys. What percent of the data is from Q1 to the median in this box plot?
25.
What percent of the data is from Q3 all the way out to that maximum?
25.
What does that mean is happening here?
Outlier.
Not necessarily an outlier, but it's skewed. So here's the deal. I've got a pretty big percent of my data right here. 75% of my data is right here. And then it kind of spreads out that way to the right. Okay? I'm going to draw you another one. Here, I'll show you. So, not necessarily. Here's what this could look like. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, could it be an outlier? Possibly, but we mathematically wouldn't know unless we calculated it, but our box plots will show us about an outlier. Now, maybe this is maybe there's seven or 8 of these. Like, there's a lot of data stacked up all the same here, and then now they're just kind of equally spread out like this. Now they're no longer outliers, it's just kind of skewed.
So the box plot doesn't show the entire data, it's just the 5 numbers.
Correct. Yes, Danny?
I know, so last year for calculus Schloss, I know you're great friends with him.
Yeah, we're besties.
Yeah, a very great friend. So he would do the test scores like
Uh-huh.
this, and then for the extreme values, if there's an outlier, you put it outside of the whisker.
Yeah, so let me show you another representation of a box plot that would show an outlier. Here's an outlier, here's another one. So let's say here's our box and whisk. Okay. Oh, this all looks so fun, right? what's this?
Stars.
What is this? This is our minimum. What's the left side of the box? What's the middle of the box? What's the upper end of the box? And this is where the rails come off. What is this?
Max.
Not the max.
Wait, what?
What are these things?
Outlier.
These are actual legitimate outliers. They were found mathematically. They are outliers. They are not, they are a part of the data, but they are actual outliers. These are outliers right here. So what is this guy?
Max.
That's your maximum right there. So this is the max. These guys right here are outliers. They were found to be outliers, mathematically speaking. I'll show you how to do that later. But what is this?
It's a gap.
That's like your 23.1.
You're so funny. Here's what that value is. This value now is the highest non-outlier. You guys knew it was coming. This is the highest non-outlier. That is my highest non-outlier. Now, can this happen on the lower end too? Can you have a lower outlier and you have like a whisker that comes to the lowest non-outlier value? Absolutely. Yes, that can happen. Okay. So again, box plots can look all kinds of different ways. If you have legitimate verified outliers, they're going to be shown in the box plot this way. Okay. This guy right here does not become a part of the 5-number summary. Nope. We just have to figure him out separately. And again, we'll go through making these in just like, don't worry about it. Like, we got this. Okay? What questions do you guys have about any of that?
I guess not.
Got nothing for now? All right. Well, let's write down how to make a box plot. What are the steps for making a box plot? Here's your first step. Number 1. Find the 5-number summary. It would seem like this would be an important thing to have if the box plot is actually displaying the 5-number summary. So, seems like we would need to have the 5-number summary. Number 2, we need to identify any true outliers. We need to identify any true, legitimate, mathematically verifiable outliers. How do we do that?
Good question.
I haven't told you that yet, okay? And I know I haven't told you that yet. Number 3. Now, this is where my box plots, I didn't draw them exactly the way that they're supposed to be done because you should draw and label x-axis evenly. You should draw your x-axis before you draw your box plot. Here's why. If you don't, every box plot's going to look symmetric because you're going to draw it that way. And you're going to be like, don't draw this. You're going to be like, wee, okay, cool. There's my box plot. And you're going to be like 1, 2, 3, 27, 42. And like, no, that's not what the box plot should look like. It should be more squished on the left and then a little further spaced out on the right. So always draw your axis first, then put the box plot where it goes. Okay, so we draw our axis evenly first, and then what we do is we mark Q1, median, and Q3, and connect. So we're making that interquartile range first. We're making the box first. It's a box and whisker, not a whisker and box. So box first. We make a box first. Then we're going to draw whiskers to highest and lowest non-outlier value. Again, I know you have to figure out how to identify outliers. We will do that. And then your final step is mark outliers with special symbol. Most people use a star or plus sign or a dot. Some people get fancy and use a happy face or something silly like that. And that is how you make a box plot. What questions do you guys have about 5-number summary or box plot and how to make them? At this point, there's probably really just one really big burning question.
How to do the outline.
How do I do the outliers? Come back tomorrow and I'll show you how.